Hello everybody, Mr. Quick here, jumping into Eureka Math / Engage New York Math, Grade 6, Module 1, Lesson 13, from ratio tables to equations using the value of a ratio. Now, we're going to look at some of our ratio tables, and we're going to restate the ratio in terms of its value. But we're also going to compare when we have the two columns in a table in a way that is very algebraic. And you're going to kind of see what I mean by that. But we're going to talk a little bit about using some of those algebraic terms and how that relates. So whether you are in pre-algebra or any other form of math, this is something you will encounter obviously now throughout the rest of the year, and then it's going to be really important down the road. So this is a good foundation building block for that. So let's jump right into it. Okay, this is example 1. This is from Eureka Math. Jorge is mixing a special shade of orange paint. He mixed 1 gallon of red paint with 3 gallons of yellow paint. Based on this ratio, which of these statements are true? So we have 5 different statements. We have to decide if they are true or false. Well, the first thing I want to do here off to the side is I'm going to do red to yellow. So I know what that ratio is. And I know it's 1 gallon of red paint. So that's 1. Then over here I know there's 3 gallons of yellow paint. So anytime they're going to make this special kind of orange, for every gallon of red, there's 3 gallons of yellow, which would mean how many gallons are in a 4-gallon mix? Well, there'd be 4, right? 1 and 3. They could also expand that. Also, we may want to go the other way, yellow to red. Well, I know that ratio, yellow is 3, red is 1. All right, so let's look at our first problem here. Okay, it says 3/4 of a 4-gallon mix would be yellow paint. Well, that would mean we know the ratio of yellow to red is 3 to 1. We may want to also add over here our total, right? So there'd be 4. So if I say 3 out of 4, well, over here it looks like 3 out of the 4 total gallons, right, would be yellow. Then that is true. Second question here says every 1 gallon of yellow paint requires 1/3 of a gallon of red paint. Well, if we're going to look red to yellow, rewrite that as a fraction, that would be 1/3. So for every 1 gallon, it's 1/3 of a gallon, right? So that does match up, and that is also true. Next question says every 1 gallon of red paint requires 3 gallons of yellow paint. Well, if we're going red to yellow, we already know that's 1 to 3. So if that was 1 gallon, this would be 3 gallons. Rewrite that as a fraction, right? 1 to 3. So if you use 1 gallon of red, you would use 3 gallons of yellow. Again, that is true. All right, so let's pop into our next question. There's 1 gallon of red paint. Oh, helps to be able to read it, right? There's 1 gallon of red paint in a 4-gallon mix of orange paint. So the total is 4, right? 1 gallon out of the 4 is red. Well, over here we have red. If the total is 4, red would be one of those 4. So once again, we find that that is true. And then finally, jump down here. There are 2 gallons of yellow paint and an 8-gallon mix of orange paint. Well, let's unpack that. 2 gallons of yellow paint. So if we're going yellow to red, it's a 3 to 1 ratio. We can rewrite that as a fraction. If there were 2 gallons of yellow paint in an 8-gallon mix of orange paint, well, we have a 3 to 1 ratio. That gives us 4 total. You can't double this to get to 8 without doubling this, right? So that one is in fact false, our only false answer. Okay, let's keep moving. Okay, on our next slide, this continues with that same problem, but we have a chart that or a table, I should say, that we want to fill out based on that information. Now, if you recall, it was a 1:3 ratio, red paint to yellow paint. So we're going to fill in the gaps here. Red paint is 1, yellow paint then is 3, right? Well, moving down, we have 1, 2, 3, 4, 5 spots. We have 1, 4, and 5 filled in. We can just logically see that this would be 2 and 3, right? 1 times 3 gives me 3, so we can check this. Is 2 times 3 equal 6? Sure does. We've got a blank space here we need to fill in. So 3 times 3 gives us 9. 4 times 3 equals 12. That's true. And then 5 times 3 we can fill in, and we would get 15. Now, the relationship, I'm going to add another column here, and we're going to look at this in a couple of different ways. If I can make it fit, and it does. Okay, the relationship here is essentially the problem, right? And so let me erase a little bit of this. Let me erase this, and I'll just rewrite that and rewrite that. The relationship is how you get there, right? So here we have 3 equals 1 times 3. That's how we got to the yellow paint. Here we have 6 equals 2 times 3. 9 equals 3 times 3. I'm kind of getting a little bit off, but that's okay. Over here we have 12 equals 4 times 3. Sloppy 3. And then here we have 15 equals 5 times 3. Now, one thing I'd like to point out now that we've looked at this relationship piece here is something we see in algebra and in other forms of math, but a lot in algebra, which would be variables. We had a bunch of empty spaces when we started, right? And in fact, I'm going to go ahead and erase those right now. We had some of those empty spaces, and you'll notice red paint, they've given it a letter, R, to represent the red paint. Yellow paint, they gave it a letter, Y, to represent the yellow paint. Those are called variables. When you have a number that you don't know, or you may not know, and instead of, you don't write a question mark, right? You represent that number with a specific letter, so you know when you use that letter what you're referring to. Anytime you would see, if we were going to try to create one of these problems, anytime you would see a yellow, you know that means the yellow paint. Or excuse me, anytime you see a Y, that means the yellow paint. Anytime you would see an R, that would mean you know that it means the red paint. So let's dive into that for a second. If we look at this top line, which we already know that the Y is 3, right? Because it's a 1:3 ratio. We could say that the red paint, which is R, is equal to, and again, going to this original ratio value, if I wrote that as a fraction, it would be 1/3. 1/3 of the value of Y. That's an algebraic equation right there, right? So knowing that R is 1/3 of Y, you can then solve for R, because R is what equals this, by using this equation anytime. Let's fill in part B here. Let me erase that so we can see it a little bit better, right? So we know that's 3. If we did not know what this is, we just would call that R, right? R equals 1/3 of Y. 1/3, when 1/3 and the variable are right next to each other, that means multiplication. But we don't put the X there, the multiplication symbol, because it looks like an X, and that can be a little bit confusing when we're talking about variables. So R equals 1/3 times Y, except in this case, we know that Y is 6. So then we can, instead of putting Y there, we can put 6. And I put it in parentheses, again, just to make sure it's not confusing. So R equals 1/3 times 6. I know if I'm multiplying, right, I'm going to multiply straight across, so I'm going to give 6 a denominator of 1. 1 times 6 is 6. 3 times 1 is 3. 3 goes into 6 2 times evenly, so my answer is R equals 2. And I would know then, up here in this exact problem, I could put a 2, right? Now, in this case, hey, we've got to have one of the pieces of data, right? We have to know one of them to be able to answer R equals 1/3 times Y. Now, if we didn't know that, then you don't know what to multiply by 1/3, and you can't solve for R. So you got to have one of them, right? And this is where we can use our math facts. We know that. But if you pop down here, we have, erase some of this, give us a little bit more room to work. We have R is 5 equals 1/3 Y, right? So we can flip it because we know what R is, but we want to know what Y is. So we really want to know Y is equal to what? Well, if you look, R times 3 gives us Y. R times 3 gives us Y. So we're going to say 3R, which is 3 times R, right? So if I know, in this example here, if I know that Y equals 3R, but in this case I already know what the R is, I know it's 5, 3 times 5 gives me Y equals 15, so in that Y space, I can write 15. Okay, we're going to talk more about this in class. I know that's a lot of examples very quickly, but I also wanted to make sure you have a video. You can go back, you can rewatch it, and we will continue to talk about it when we're face-to-face here. So, anyway, thank you for watching.